Everyone, I'm Pankaj Singh, welcoming all of you on the Drishti online platform, and we are doing the 7th episode of what 100 most important topic of for Prelims 2026, and it is for the geography. And before moving to the next, let us see the questions that I have given in the 6th episode. Solve it. So let us start solving those questions, and the topics are it is based on the salinity, it is based on the ocean temperature, and then ocean salinity, and then ocean density. And here that the question that we have to see, and again I am saying that if you have any kind of a doubt in the what answers, go back and see the what I say that last video, sixth episode video, and then it will be helpful for your. So here we are watching out that sodium chloride, consider the following statement: sodium chloride constitute the largest proportion of dissolved salts in the sea water. Yes, this statement is you can say that it is absolutely correct. And then second statement that the principle of constant composition states that the relative proportion of major salts in the sea water remains nearly constant. Yes, this is also, you know, the sodium chloride has the highest 77.7% ocean, any kind of salinity, but that sodium chloride will be 77.7% around, and magnesium chloride 10.9%, and then magnesium sulfate it is 4.7%, calcium sulfate is 3.6%, and potassium sulfate 2.5%. This constant proportion will be always same anywhere in the any ocean. So therefore this statement is correct. Magnesium sulfate is present in greater proportion than the magnesium chloride. No, magnesium chloride is 10.9%, and magnesium sulfate it is, I said, that 4.7%. so it is a wrong one. So with on the basis of that 1 and 2 only is correct. And then next that we have to see, it is about consider the following statement, and then equatorial region shows the highest salinity values due to intense solar radiation. So equatorial region salinity is not highest, it is 34 to 35. Subtropical zone has 36 to 37, that is around 36.5. So that is not, I said that not the highest one. So this statement, it is what you can say wrong one. And then second, the persistent cloud cover in the equatorial region reduces evaporation from the ocean surface. Yes, if the evaporation is going on, if the cloud is there, the evaporation will reduce, and therefore salinity is also less. The freshwater input from the rainfall plays a dominant role in determining salinity in this region. Yes, there is also freshwater mixing reduces salinity. So statement we can say that option C 2 and 3 is only correct. Now the next one that we are going to see, the consider the following statements regarding subtropical zones. These zones are characterized by higher salinity compared to the equatorial region. Yes, subtropical has higher salinity 36 to 37, and equatorial has 34 to 35. And then second statement, high evaporation and low precipitation. High evaporation and low precipitation are the main cause of increased salinity in this subtropical zone. Yes, this is also correct. Persistent cloud cover in these regions enhances salinity by trapping heat. There is no cloud cover in this subtropical zone. So this is what I said, that wrong one. So we can say that option A 1 and 2 only is correct. Now that we can say here that consider the following statement regarding vertical distribution of ocean salinity. Vertical distribution, there is a surface zone or mixing zone, there is halocline, and thereafter deep sea. So the surface layer shows a high variability in salinity due to factors like evaporation, precipitation, and wind driven mixing. Yes, this is correct one, and this statement is correct. And second statement, the halocline zone is characterized by uniform salinity with depth. No, there is a rapid decrease in salinity in the halocline layer, so this statement is wrong. The deep zone has relatively stable salinity due to limited or no influence from the surface process. Yes, and this is what a right one, and we can say that 1 and 3 only is correct. Again I am telling you, if you have any kind of doubt, go back and see the 6th episode, it will be immensely helpful for you. And next question that we are going to see, it is about consider the following statement regarding factors affecting ocean salinity. Factors affecting what I said, that ocean salinity, that river discharge increases salinity by adding dissolved salt into the ocean. No, river discharge decreases salinity. So this is what wrong. Increased evaporation leads to higher salinity as water is removed, but salts remain same. So therefore I can say that this statement is right one. And increase the precipitation due reduces salinity by adding diluting seawater. Yes, this if a rainfall water mixes fresh water, therefore salinity is decreasing. So this statement is right, and you can say that statement 2 and 3 is only correct. Now the next one that we are watching, consider the following statement regarding horizontal distribution of ocean temperature, and higher ocean temperature are always recorded exactly at equator. Yes, that is what 27 to 30 parts per thousand ocean temperature is there. Sorry, 27 to 30 degrees Celsius ocean temperature in the what equatorial region, and in the subtropical region 22 degrees Celsius. In the mid latitude it is in a 10 to 14 degree, in the polar region 0 to 2 degrees Celsius. So this way you can say that highest ocean temperature always recorded exactly at the equator. Please go and see why it is happening and how it is happening. And that subtropical regions often record less temperature than the equator. Yes, this is also correct. And temperature decreases uniformly from equator to poles. This is also correct. All the statements are correct, and 1, 2 and 3 you can say. And here consider the following statement regarding thermocline. It is a layer where the temperature decreases rapidly with the depth. This statement is correct. Rapidly decreases with depth. And it is the strongest and permanent tropical region. Yes, it is the strongest and permanent in the tropical region. Yes, it is correct one. And it allows free vertical mixing of vertical nutrients between surface and deep waters. No, this thermocline layer does not allow surface water to mix with the deep sea. So it is not mixing. So this is the wrong one, and we can say that 1 and 2 is only correct. And thereafter we can be able to see, consider the following statement regarding ocean water density. Ocean water density decreases with decrease in temperature. Yes, if the temperature is less, that the ocean water density will increase. Temperature and density, it is an what inverse relationship. The ocean water density increases, not decreases, with the with decrease in temperature. So here it is in a wrong statement. Salinity has a direct relationship with the density. If the more salinity, more density. Yes, that's a correct. And less salinity, less density, that's a correct one. Warm ocean water is denser than cold ocean water. No, cold water, it is in a compressed one. Molecules are very close together. Therefore, cold water has what I say that more density. So this statement we can say that warm ocean water is denser than the cold ocean water, and this statement we can be able to say that it is wrong, and on the basis of that we can say that 2 only is what correct. Now we are going to see that statement 1, and it is in a consider the following statement of UPSC 2025 question, and it is in a based on a specific hit. So the next 3 questions that we are going to see in the based on the specific, and I explained in the 6th episode. Please go and check it out, then it will be very easy for you to understand that. And statement 1, in January the northern hemisphere the isotherm bends equatorward and over the land mass. Yes, it is in a bending equatorward over the land mass and poleward while crossing the ocean. So statement this one is correct one. Statement 2 says that in January the air over the ocean is warmer than over the water land masses in northern hemisphere. Yes, this is also correct, and we can say that both the statement 1 and 2 are correct, and what statement 2 explain the statement 1, and this is correct one. And the next I can say that which of the following is our correct inference or inferences from the isothermal maps in the month of January. Here the isotherms deviate to the north. It is the same kind of the last. The same kind of the last isotherm deviate to the north over the ocean and south over the water continent. This statement is yes correct one. And the presence of cold ocean current, Gulf Stream, North Atlantic drift makes the North Atlantic Ocean colder and isotherm bent towards the north. Already that the cold ocean currents, Gulf Stream is in a warm ocean current and the North Atlantic drift is in a warm ocean current. So it is in a warm ocean current. It means already it is not a cold ocean current. This statement is already wrong over there. So and we can be able to say that the statement A 1 only is what correct. Now consider the following statement of UPSC 2023 that the temperature contrast between continents and ocean is greater during summer than in winter. So the temperature, it is in a contrast during the winter is more, in the summer it is less. Go and check it out. Yes, this is a wrong statement. Statement 2, the specific heat of water is more than the land surface. Specific heat of water is 4 times more than the land. therefore the land get heated fast and the colder also fast. More less the specific heat, there will be more heating fast, more losing heat fast and become colder fast. But if the specific water is more, if it takes more time to get heat up and more time to get reducing the heat. So this statement 2 is only correct, and we can say that statement 1 is incorrect, statement 2 is correct. So option D is only the option which is correct. So these are the questions we have to see. Now we have to see that in this 7th episode we have to talk about heat budget of the earth, insolation, albedo, urban heat island, atmosphere, basic composition, and we will see layers of atmosphere. These are the topics that we have to see in this region, and which is very much important for the prelims 2026. And here first of all, heat budget. If I am talking about heat budget and heat budget, suppose here if I say that this is our earth surface, and in the earth surface and we can say like when the sun rays are coming, insolation, incoming solar radiation, when the sun rays are coming, in this one you can say that it is an insolation. I have said that there is an insolation is there, and it is in a frequency is very high. So this, you know that this is known as a distance between these two vibration, that you can say this kind of it is known as a crest, and this is known as a troughs. It is not the part of that, but I have to say that this is a wavelength. So if I say that like in between the wavelength is short, so we can say that incoming solar radiation which is coming from the sun, it is always what I said that a short wave. It is always in a short wave, and after when it is reaching to the earth's surface, what happened after reaching to the earth's surface, you can say that it reflects back because of a large amount of heat has been utilized and its energy reduced. When the energy reduced, the frequency reduced. Frequency reduced means in a wavelength increases, and this is what we can say that earth radiate back heat in the form of what I said that long wave, and it is known as a long wave. You can say that terrestrial radiation. So you can say that the earth is maintaining terrestrial radiation. Earth is maintaining what I said that heat budget thermal equilibrium between incoming short wave, incoming solar radiation, and then outgoing. You can say that there is a long wave terrestrial radiation. So that's what you have seen over here, that it is in the earth maintains the thermal equilibrium between incoming solar radiation short wave and outgoing terrestrial radiation, and this balance is called the heat budget. And what is the meaning of balanced heat budget? Balanced budget means 100 came, 100 gone. So this is the balanced budget. You can be able to say that 100 unit has to come and then 100 unit has to go back. So this is about, I said that in the sun there is 100 units of incoming solar radiation of what I say that you can say that in the it is coming from the sun towards the earth's surface, and here we can talk about like out of this 100 we can talk about that which is the 100 unit which is coming from there. This 100 unit, suppose it is coming out of that yes 27, I said that 2762, what do you have to say, 2762, out of that 27 unit it is in a directly 27 unit is directly reflecting by the what I said that upper atmosphere and the cloud. You can say 27 unit is directly reflected back, and then 6 unit you can be able to say that there is an atmospheric particles are there, and the 6 unit it is in a reflect by the the atmosphere, the particles which is available, and the cloud is 27 unit particles, atmospheric particles, they are reflecting back 6 unit directly without any use. And then on the earth's surface there is an ice coverage is there from the ice directly. Ice is a white color, it directly reflect everything. So the T2 unit is reflected back. So we can say there is a 27 plus 6 plus 2, 35 unit is what I said that without any, out of 100, 35 has been removed, reflected back, and we can say that it is in a albedo of the earth, and that is 35 you can say, or you can say 35% means out of 100, 35 has been reflected back. This if this albedo, if incoming is more, if suppose now if the what I said that if this albedo, if I said that reflecting back is more, now 40 is reflecting. So in coming towards the earth will be less, earth will be relatively cool. If the albedo is less, if the albedo means suppose 30 unit is going, so the earth will be hitting. If the albedo is less, earth will more hitting, and if the albedo is more, the earth will have what? Less hitting, cooling effect, you can say. So this thing we have been able to say, and after that we can say like out of this 35 has been gone, so now 100 minus 35, yes, 65 unit is coming towards the earth's surface, yes or not? Now out of this 65 unit we can be able to say like that this 65 units, what in this 65 units you can say that 14 units is absorbed by cloud, it is absorbed by the cloud, you can say that absorbed by the cloud, and the rest 51 unit which is reaching to the earth, rest 51 unit. So here you can say that cloud, it is in a 14 unit absorbed, 27 reflected back. Listen me, in the last part where I said that 27 directly reflected from the top of the cloud, it is not absorbed, it is in a reflected back. And here if I'm talking about 14 unit cloud absorbed, and after the rainfall also reflect back. After rainfall also, what I say that also reflected, what also released, better to say released in atmosphere. So how much it is only able to reach to the earth's surface? So what you can say that only you can say that 51 unit is able to reach earth's surface, 51 unit is able to reach earth's surface. From this 51 unit we can be able to say that you have to say some numbers, 17, 23, what I said that 17, what I said that 17, 23, 11, what I said that 17, 23, 11. So there are the processes of releasing the heat, you know that how it is, radiation, the heat moves from one region to another region, how? Through the radiation, through the evaporation, through the conduction, through the convection. So from this one, and now the earth is radiating heat in the form of what? Long wave, and in which one? 17 unit, it is in the form of terrestrial radiation. Earth has radiated a terrestrial radiation, and terrestrial radiation, that is what 17 units. So now after that 51 unit, you can say that after the 51 unit minus 17, you left with the 34 units, and out of those 34 units you can be able to say that the rest 23, out of this 34 we can say that 23, and there is what? 11. So this 23 is releasing into the atmosphere in the form of that ocean is making what? Hotter, it becomes a water vapor. This water vapor goes over there, forms a cloud, and after the rainfall, those cloud which is water vapor from the heated sea surface water form water, inside the water vapor there is a heat has been hidden, and that heat hidden goes up upper in the atmosphere, and after the cloud condensation they release the heat and the rainfall takes place. The heat has been released in the form of evaporation, and it is hidden inside the water vapor, therefore it is known as the latent heat of evaporation. And this fundamental understanding when understand in the cyclone latent heat of condensation also. So from the latent heat of evaporation, 23 units released by the cloud formation, by the cyclone formation, whatever it is happening in the all atmospheric phenomena, and in this one the vapor it is forming and then releasing the heat, it is known as a latent heat of evaporation. That is you can say that latent heat of what? Evaporation. The latent heat of evaporation means this heat is hidden inside the water vapor. Evaporation. So latent heat of evaporation releases 23 units, and then thereafter 11 units in the form of warm air is moving up. When the warm air is moving upward and taking the heat towards upper surface, it is known as convection, and then heat is also moving in the form of conduction. So through the 11 unit, it is moving upward in the form of what you can say convection, and what I said that conduction. So this way we can be able to say that the heat is moving into the atmosphere. So all this is what you can say that 51 unit come and then 51 unit gone back. into the space. And here we can be able to say like so what we have seen that out of 100 units of solar radiation, the 35 units reflected back, that is a 27 from the cloud, atmosphere 6, and the ice surface 2, that is known as a total 35, and this is known as a what, albedo. 35 units moved, and out of 65 units what 14 is absorbed by the atmosphere, that is in a cloud, it is what absorbed by this, and then 51 is able to reach to the earth surface. And then earth re-emits this 51 as in a long wave. Long wave means terrestrial radiation, and here you can see that infrared radiation, the long wave terrestrial radiation. Infrared, long wave is always the infrared, and you can be able to say that here in this one you can say that the 17 units is released long wave radiation, terrestrial radiation from the earth surface, yes or not, and then evaporation of water 23 units, you can be able to say that latent heat of evaporation you can be able to say, and then 11 units you can be able to say as a conduction, and what it is in a convection. And this is the way you can be able to say that these heats are going to be what I said, that releasing into the water atmosphere 51 unit cam, and then 51 unit has gone. So yes, if I have to talk about another important part of it, it is talking about, yes, if it is in this earth, on this earth, if it is coming like all in the sun which is coming over there, out of that you can say in the sun insolation, three things are there. Insolation means incoming, you can say that incoming, sol means solar, and sun means radiation. So the incoming solar radiation which is coming toward the earth's surface, in this one you can say that first of all there is what, around 42 to 50%, it is you can say that there is visible rays are there, visible rays are there, visible rays, and visible rays we can be able to say that VIVGOR, that violet, indigo, and blue, and what I said, that green, yellow, orange, red, these are their visible rays. And the second one we can be able to say that around 43 to 54%, it is your what, infrared rays are there which is coming, and remember that only half of around. And third I said that you can say that 3 to 8% it is in a UV rays, and this UV rays are absorbed by, yes, this UV rays are absorbed by, yes, upper ozone, upper atmosphere ozone, must remember that. Here now moving toward the, in this area, when here now heat budget of the earth, we have seen that out of the 51 units radiated by the earth, long wave radiation atmosphere 17 units we have seen, yes, and then latent heat of evaporation 23 units used in the evaporation, stored as a latent heat, and later released in the atmosphere, cloud formation, rain, whatever it is. And sensible heat means conduction and convection, transfer the heat 11 units. Is it okay? These are the units which is there. And now consider the following statement regarding the earth's heat budget, and you have to answer very by understanding this topic. The earth maintains thermal equilibrium through a balance between incoming short wave solar radiation and outgoing long wave terrestrial radiation. Yes, you have to see whether it is right or wrong. And then second statement, approximately 35% of the incoming solar radiation is reflected back into space, which is known as albedo. You have to say whether it is right or wrong. The entire absorbed solar radiation is retained permanently by the earth's surface, whatever 51 unit is going, it is entirely, it is permanently absorbed or released or not. So you have to say whether it is right or wrong. So you have to give answer accordingly. We are moving to the next, it is, and I said that about another topic we are going to see insolation, that the heat which is coming toward the earth's surface. and we can say that the solar energy received at the Earth's surface is known as an incoming solar radiation. Yes or not? And insolation definition we are watching, and how we are measuring that amount of heat means watt per unit meter square. So in 1 square meter, how much heat is coming, that is known as an incoming solar radiation, and it varies with time and space, not uniform across the Earth. You know that if the Earth is coming toward vertically, when it is going slant, the energy distribution is decreasing. Energy distribution is what I said that because when it is coming into the smaller area. So suppose in this smaller area, when the heat is coming in this vertical form, so suppose I said that 1000 calorie heat it is coming in the what I said that 1000 watt. Suppose I am talking about, yes, in the form of what suppose 1000 watt of heat it is coming in what I said that 1 meter square. And if the same if I say that if the same rays are going in the slant form, the same rays are going in the slant form, it is same rays slant, it is becoming 1000 watt, it is going into what I said that in the 10 square meter. So if I have to cancel 0 it will become 100 watt 1 square meter. So here it will be more heated, it will be relatively less heated. Here the temperature will be 30, here the temperature can be what I said that 10 degrees Celsius. So here 30 degrees Celsius. So now you can say that slanting of the heat, it is also means the insolation is important. Now the factors affecting the insolation, now we have to see which are the factors affecting the insolation. Latitude. So with increasing latitude, the slanting of sun rays is there. Yes or not? That's important. And this is also known as the angle of incidence. Angle of incidence, duration of the day, Earth sun distance, and this is in the Earth sun distance means perihelion, aphelion, and atmosphere means cloud coverage. These are the important, I said that the factors affecting the insolation. The first one I said that latitude, the most important. Equator, direct sun rays are coming. Right now we have been able to say that at the equator the direct sun rays are coming more heating, so we can say that 1000 watt per meter square. But when it is going into the slant, it is covering large area and it is covering 100 watt per meter square. Suppose I am giving an idea. So the heating, I said that depends upon the latitude. So maximum insolation is the in the low latitude, and the poles, the rays are what I said that oblique or slant, therefore less insolation. Is it okay? So here we can be able to say in this region more insolation. And now moving toward the next, here angle of incidence, already I have discussed. If the angle of incidence is 90 degree in this region, you can say that again the same thing, we have to talk about 1000 watt per meter square, and here we are covering what I said that larger 100 watt per meter square. So heating is what large surface area is sprayed at the heat, and here is a smaller surface area and then same heat is there. So this way you can be able to say that heating, vertical rays concentrated energy in a particular region, and then slanting rays is sprayed over the large area, therefore you can say that heating is what reducing, temperature decreases. And after that you can say that duration of the day. Next one we have to talk about duration of the day. Longer the day, if the daytime is very long, if the daytime is what I said that in the you have seen in the month of March, April, May, month, you can be able to say there is an around 13 hours 14 hours day. Morning it is around 5 o'clock, and then around 5:15 something like that, and evening is taking place by the 14 hours day. So sun rays are coming for longer time, so there will be more heating. If and in the during the November, December, we have seen that the December months around that the sun rays are coming, the morning is taking place around 7, evening is taking place for that the sun setting is around 5 o'clock. So only 10 hours day the sun heating is coming less. If I said that you can say the shorter the day, if the shorter the day heating is less, weak heating, and if the longer the day, heating is more. So longer the day is strong heating, you can say. Short day it is in a weak heating, you can be able to say. So it depends upon, I said that longer and shorter day. Is it okay? After that we can say that is in a factors and in a Earth sun distance. In this one it is in a perihelion. On the 3rd January there is in a condition like perihelion. On the 3rd January Earth is, we can be able to say that it is in a nearest, and Earth, you can be able to say that slightly bright. It is, and I said that nearest more heating it is there, and on the what you can say that on the 4th July it is around 152 million kilometer, and here it is in 147 in the perihelion. Aphelion means away on the July 4th, you can say that. So that Earth is receiving less heat on the 4th July, and on the 3rd January receiving relatively little more. And how much it is, the difference is what? 7% of minor difference. So during the perihelion, when P4 pass means somewhere nearest to the Earth, and then I said that it is in around 14.7 crore, and it is in a aphelion away on the 4th July, it is in a somewhere, it is in a 15.2 crore kilometer. So there is this kind of effect minor of 7%, you can say. And here I said that atmosphere is also playing an important role, you can say. And then there is a cloud coverage, dust, water vapor, and then reduces insolation. If we can say that if there is a cloud coverage, it will be there, the sun heating will be relatively less. And in the equatorial region, the same thing happen because of the cloud coverage. You can say that the heat which is coming less after every day between 12 to 2 p.m. there is a cloud formation is there, and because of the heats are able to come less over the Earth's surface in the equator. So 12 to 2 there is a cloud formation, and the 2 p.m. to 4 p.m. rainfall in the equator. So because of that, that equatorial region temperature does not able to exceed 30 degrees Celsius. But in the tropical region of India, like I say, the cloud coverage, when it is not there, the heating is more. Sometimes the people thinking that equator is more heated than the equatorial region is more heated than the tropical. Yes, there is a sun is where it is coming more, but if the cloud reduces the heating intensity, so the cloud, dust, water vapor reduces insolation. Is it okay? Consider the following statement regarding insolation. The insolation refers to the solar radiation received at the Earth's surface. It is talking about solar radiation, how much receiving at the Earth's surface, we have to answer it. And the insolation is maximum at poles due to longer duration of daylight in the summer. So you have to, what I said, that insolation is maximum at poles due to longer duration of daylight in summer. You have to answer this question. The angle of incidence of solar rays affect the intensity of the insolation. So angle of insolation, if the angle of insolation is more and then the slant, solar rays affect the intensity of insolation. You have to say whether it is right or wrong on the basis of that. Now next one, we are talking about albedo. Today we also understand that albedo, it is in a fraction of incoming radiation reflected back to the space. Out of 100 unit, we have seen that 35 unit is reflecting back. That is known as the albedo of the Earth. So whatever the fraction which is coming, that the fraction of the sun rays which are coming, out of that how much it is reflected back. So the fraction of incoming radiation reflected back to space, and when there is a 0 means no reflection, when there is a 1 total reflection, 1 cam 1 released. So ice is 1 cam 1 release, means whatever it is coming. So ice surface has a high albedo. Ice has a what, you can say that high albedo. After that, there is a cloud is also albedo. Which has more albedo, it will reduce the temperature. Which has more any, it will reduce the temperature, high albedo. But the desert, you can be able to say that it has an also moderate albedo. It also releases coming and the reflecting back. But forest is the one, is what, dense forest absorb more heat, reflecting less. And ocean water is the lowest albedo, and you can say it absorbs more heat, yes or not, and releasing very less. So which has the, what I said, that highest albedo? It is, I said that snow has highest. Second, it is coming for the what, cloud, and then thereafter desert, thereafter what, forest, and thereafter we can say that ocean is the lowest. Means the lowest albedo, the ocean absorb largest amount. If the albedo is less, absorbing more heat, more heating, and albedo is more, then it will reflecting more, and then less heat is coming and reducing the temperature, cooling. So here albedo we have talked about. Here what albedo controls reflectivity, that controls the Earth's temperature. High albedo, more it is reflecting, means cooling. Low albedo means warming. So ice, now we have to understand what is the positive feedback loop. You know that suppose ice is melting, ice will melt, then the ice region will be, ice has a more albedo, you know that ice has what, It is coming and then reflecting it. But due to the ice melt, you know that the ice area is releasing, means albedo of ice will decrease. Yes or not? If ice melt, the surface area of the ice will, then you can say that ice melts, albedo will decreasing, and then less reflection. Yes or not? Less reflection. Earlier this much of the ice is there, more reflection is there. Now ice melting, it has reduced, the less reflection, and here in the ocean more absorption. Yes or not? Ocean is the lowest albedo, it will be more absorption. So you can say less reflection, and then it will increase more absorption by the ocean. Is it okay? And if there is a more absorption, means more hitting, and then again more. Now this ice which is left over there, it will further less, and then further less, more absorption, less reflection, then further more hitting causes further ice to be finished. The one day, it is known as an ice melting is in a positive feedback loop. It itself, it is in a help in what increasing the heat again and again, and more heating, more ice melt, more heating, more ice melt. So it is known as, I said, that more warming, more melting, and it is in a positive feedback loop. Prelims traps that ocean have a low albedo but a high heat capacity, means it absorbs low albedo, therefore you can say that it absorbs the more heat. Yes or not? Cloud can both, it can reflect and it can trap the heat. Listen me, in the top it is reflecting, and cloud is also helping. I said that it is in a reflecting back, and when I said that when the heat which is coming onto the earth's surface and then reflecting back in the form of terrestrial radiation, this cloud also help in what I said, that this long wave radiation is an less power, and it is what I said, that long wave radiation of the terrestrial, it reflect back, it also help in heating. Here it is helping what? Heating. And here albedo reflecting from the top, it is helping what? Cooling. So the cloud, you can say that reflect means cooling and trap heat. When from the earth's surface it is what release heat, it is what help in heating. So here consider the following statement regarding albedo. Albedo is the fraction of incoming solar radiation reflected back into space, that we have to say whether it is right or wrong. Another one, I said that second statement, surfaces like fresh snow and clouds have low albedo. Yes, you have to say whether it is ice or cloud has low albedo or not. Oceans have high albedo, therefore reflect most of the incoming solar radiation. Ocean have high albedo. It is talking about ocean has high albedo. You know that, and therefore reflect most of the incoming. So you have to see whether which one is correct regarding that. Now we have to see urban heat island. If I am talking about urban heat island, means urban areas are warmer than the surrounding, and what is the temperature difference of the urban area related to the surrounding village area? Temperature difference can be 2 degree to 8 degrees Celsius. And here what happened in the urban areas, there is roads and all are there, concretes, asphalts absorb more heat, means low albedo, more absorbing heat, not less reflecting, it is in a more albedo, less albedo. Vegetations in the urban areas are also less, therefore I said that, you know that evaporation also reducing temperature. Suppose water is what I said, that heat is absorbed by the plants and all, so they will release the heat by evaporation and they become cool. We are also by evaporation, sweating, we are reducing our temperature. Yes or not? But if the vegetation is not there in the urban area, then there will be more absorption, means less evapotranspiration, means when the plant release the evaporation, it is known as an evapotranspiration, or less cooling. So there will be a more heating will be there. There is no waste heat from the vehicles, industries, ACs. They are what I said, releasing more heat into the atmosphere. Urban heat island. Urban geometry, tall buildings trap heat more, and reduced wind circulation also able to what I said, that wind circulation is more inside that in the earth, so not able to able to meet with the outer wind of the urban areas. The outer wind, which is relatively cooler, is not able to enter into the urban areas. We can say that is an urban heat island. And here the key features, urban heat island, you know, is stronger at night, because heat stored during day is released in the night slowly. Then you have to, what I said, that heat absorbed, because the everywhere jungle of concretes, tall building, high skyscraper building, all these are there. So when you are releasing the heat at the night time, it's slowly. Therefore, urban heat island felt more in the night time in comparison to daytime, because I said that urban heat island is stronger at night. And impacts, heat waves intensify, हर जगह heat waves, loo is moving. Health risk, there is a problem to the what human being, they can be, I said heat stroke can be there, and then they can go to the hospital, and there is sometimes fatal also. Increased electricity demand, more heating means more AC, and all these things will be there, it will be running. And there will be also air pollution, it is also helping in what, catching the air pollution. How to mitigate? Everywhere try to make greenery over the roofs everywhere, so that they can be absorb the heat in this area, making the cooler climate. Urban forestry into the what, urban area. Cool roofs, high albedo paints, any kind of painting or tiles if you are making, so that they can reflect more heat from the top of the surface of the your roof. Water bodies should be there, more wetland, more lakes in the urban areas and all, and there will be wetland ponds and all, that will help in reducing the temperature. So we can say that consider the following statement regarding urban heat island. Urban areas tend to be warmer than the surrounding rural areas due to human activities and surface characteristics. Again, urban areas tend to be warmer than surrounding areas due to the human activities. You understand, surface characteristics, what kind of roads, what kind of buildings and all. Second, high albedo surfaces like concrete and asphalts are major contributed to what, urban heat island effect. That's what it is we have to see. And the third statement, urban heat island effect is generally more intense during night time. Yes, just check it out which options are correct regarding that. Next one that we are going to see, you know that atmospheric basic composition, in the atmosphere nitrogen 78%, and it is an inert gas. Generally it nitrogen fixation is taking place, but a part of that, it dilutes oxygen. If the 78%, suppose nitrogen is 20% and oxygen is, I said that 78%. So oxygen will help in more combustion, everywhere combustion, yes or not, more heating, more fire, but it has balanced oxygen only 21% and 78% nitrogen. If in air, suppose that there is a fire is there and there is a nitrogen and 78%, 21% oxygen. After the fire has been taken place, after certain period when 21% oxygen has been utilized, then there will be, we can say that no fire will stop automatically, because only nitrogen is available there. So nitrogen help in diluting what effect of oxygen. So here dilutes oxygen. Is it okay? And you can be able to say that there is what oxygen is what 21%, it helps in respiration, it helps in combustion. Argon is there 0.93%, carbon dioxide, which is a greenhouse gas which helps in absorbing. I said that carbon dioxide, yes, carbon dioxide, methane, there is a nitrous oxide, there is a sulfur hexafluoride, there is a different kind of greenhouse gases are there. So this I said that carbon dioxide is one of the greenhouse gas which is, I said that, absorbing the what heat more. And a part of it, there is in the atmosphere there is a variable amount of gas is there, water vapor is there, and ozone is also there. Water vapor, it is also, I said that in the form of control weather and climate, it is making in a weather, climate, and maintaining the temperature also. And what I said that ozone layer, which is, I said that harmful UVB and harmful UVC rays absorbed from the top. This ozone is dangerous. It is a good for in the stratosphere. In the stratosphere, ozone is there, which help in, I said that, absorbing UVB and UVC. It is not able to come, otherwise we will be facing cancer and different kind of problem, more heating also. And therefore, but in our lower atmosphere, there is also we are making ozone through the volatile organic compound and nitrous oxides. There we are making this kind of what ozone, which is harmful in the lower atmosphere. So water vapor and dust, if I am talking about control weather and climate, dust is there on which cloud condense, the cloud formation condition take place. water vapor and all. You can say that water vapor, hurricane, dust particles, all are there, which is helping that. So this is the basic composition. We have the different nitrogen, oxygen, argon, carbon dioxide, water vapor, dust particles are there, and ozone, which is doing something. Nitrogen is the most consider the following statement regarding composition of air. Nitrogen is the most abundant gas in the atmosphere and helps in diluting the oxygen. You have to answer it whether it is right or wrong. Oxygen supports combustion and respiration, that we have to say whether it is right or wrong. Carbon dioxide is the most abundant greenhouse gas in the atmosphere. You have to check it out, yes all. So which options are correct regardingly, we have to give an answer in the comment box. We will see in your answer in the comment box, and even if you have doubt, we will see. Another one, I said that layers of the atmosphere. Know that till 18 kilometer height you can be able to say there is some kind of troposphere. It is a more at what I said that it is more over, you can say that it is a more over you can say like this troposphere. If I am talking about that's a troposphere. If it is in a earth, it is in a 0 degree equator, it is in a poles, and because of the warm convection of warm water vapor, the troposphere is up to the 18 kilometer above equator, because there is a convection of warm air. But in the polar region, 0 degree, there is a 90 degree north, or in the 90 degree south, there is no convection. So here the height is around 8 to 10 kilometer. So troposphere height is 8 to 10 kilometer in the polar region, and here it is 18. Why? It is convection of warm air. So here, and all weather phenomena, tropical cyclone, cloud formation, all weather phenomena, temperature decreases with the height and all, it is happening in this region. So troposphere, the troposphere we have seen in this region, there is a troposphere. After that, stratosphere, ozone layer is there, which is helping in the absorbing UVB and what I said that UVC rays that we have seen. In the ozone layer, this is mostly concentrated, this ozone layer is mostly concentrated in 20 to 30 kilometer, and below there it is below in the stratosphere, our aeroplane jet aircrafts is to move. There is in the mesosphere, it is in a middle sphere 50 to 80 kilometer mesosphere. In this one, with increasing height, temperature decreases, and when the meteors which are coming, they fire, and then it is in they fire in this region, converting into shooting star and help us our protecting in our earth. And in this thermosphere 80 to 400 kilometer, which is also having lots of ions, it is known as an ionosphere, and this is the thermosphere, ionosphere, both are same. In this region, our International Space Station, and in this region, North Pole, above North Pole there is an aurora borealis, and above South Pole aurora australis. Different phenomena are moving, and there is a low Earth orbit also exists in this region. This is an exosphere from the 400 kilometer above. Satellites are also moving in the low Earth orbit. So here we have been able to see some kind of ideas related to that, and here we can say that consider the following statement regarding the layers of the atmosphere. All weather phenomena occur in the troposphere. We have to see whether it is right or wrong. All weather phenomena. The ozone layer is primarily located in the mesosphere. You have to say ozone layer is in the mesosphere, stratosphere. What you have to see? Meteors burn up in the mesosphere due to friction with atmospheric particles. Yes, everywhere it is a friction is important for burning. So we have to say whether it is right or wrong. Which options are correct regarding that? You have to see into it. Another question that we have to, the atmosphere is heated more by incoming solar radiation than by terrestrial radiation. I have already said that Earth, which is I said that heating, when the Earth is radiating the heat, cloud is absorbing, and then mostly Earth is heated more by the terrestrial radiation, not by the incoming. Incoming is not. So you have to see carbon dioxide, another greenhouse gases in the atmosphere, good absorber of long wave radiation from the Earth. Earth radiating long wave radiation. We have to see whether it is right or wrong. Accordingly, we will see in the next episode. I will see your each answers, and then accordingly, I'll in the 8th episode we will see that all the question answers. Is it okay? So I think you must have enjoyed, and we'll further in the 8th episode we'll come with the another most interesting topics of the geography, which is very much important for this prelims 2026, and till then we'll see like this.
For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.